Hello, I'm Ismail Mohammed. Welcome again to our solving section mathematics for Form 2 topics, and today we will look on the question involve Pythagoras theorem and trigonometrical ratio. This is our 8th topics. So let's now start with the first question here. The first question says a right angle triangle is inscribed in a semicircle XYZ as shown below. Find the radius of the semicircle. So we have right angle triangle inscribed in a semicircle. We have to find the radius, this distance. But first we have to find the diameter, then we can find the radius. How we can find the diameter? Just to apply the Pythagoras theorem, because we have xy is equal to 12 and yz is equal to 5. So we can use Pythagoras theorem to find xy. Pythagoras theorem, if we have right angle triangle, this one, this A and this B and this C, so the hypotenuse, the square of hypotenuse is equal to the summation of square of the other side. So we can apply this rule here to solve our question. Now here hypotenuse is this distance, is the hypotenuse, because the triangle is in this side. So xz, if xz is the distance, so xz is square is equal to 12 square plus 5 square by applying Pythagoras theorem. Pythagoras theorem. Now xz square is equal to 144 plus 5 square, which is equal to 25. So xz square is equal to 169. So xz, we put square root both sides, so this is equal to 13 plus or minus, but here we take the positive answer. Therefore the radius of our triangle here is equal to 13, but you are told to find the radius. 13 is the diameter of right angle triangle, so the radius is equal to diameter over 2. Diameter is equal to 13, so here we have 13 over 2, which is equal to 6.5 centimeter, and therefore the radius of the semicircle is equal to 6.5 centimeter. Let's now move to question 1b. In a right angle triangle, the hypotenuse is 5 centimeter long and its perimeter is equal to 12 centimeter. Find the area of triangle. So we have a right angle triangle with hypotenuse 5 centimeter and perimeter is equal to 12 centimeter. You have to find the area of this triangle. We know that area is equal to half times base times height. So we have first to find the height and the length of the height and the length of the base of this triangle, so as we can be able to find the area of triangle. How we can find them? We were given the perimeter of our triangle. So if the height of a triangle is equal to h and the base is equal to b, then h plus b plus 5 is equal to 12, the perimeter of our triangle. So here b plus h plus b is equal to 0, is equal to 12 minus 5. So h plus b is equal to 7. That's this equation 1. But also this is right angle triangle, so you can use Pythagoras theorem Pythagoras theorem, so we can get another equation, and hence we can find the value of h and b. So from our triangle here, hypotenuse is equal to 5 centimeter. So from Pythagoras theorem, 5 square is equal to h square plus b base square. Pythagoras theorem. So here I get 25 is equal to h square plus b square. So this is another equation. So simply let's make subject h from first equation. From equation 1, h plus b is equal to 7. So h is equal to 7 minus b. So let's substitute the value of h into the second equation. So 25 is equal to h is equal to 7 minus b whole square plus b square. This is 7. So here we have 25. We have 25 is equal to, here you get 7 square minus 2 times 7 times b plus b square. And here also we have b square. So we get here h plus b is equal to 7, and also h square plus b square is equal to 25. So we have to find the value of h and b. So from equation 1, let's make h subject. H is equal to 7 minus b. Now let's substitute the value of h into the second equation. So here we'll get 7 minus b square plus b square is equal to 25. So here we get 7 square minus 2 times 7 times b plus b square, and this one plus b square is equal to 25. So here we get 49 minus 14b plus 2b square is equal to 25. So 2b square minus 14b plus 49 minus 25 is equal to 0. So 2b square minus 14b, here we get 49, 9 minus 5, we get 4, we get 24 is equal to 0. So we have to solve this quadratic equation. First we have to divide by 2, so we'll get b square minus 7b plus 12 is equal to 0. By the method of factorization, first we have to split the middle term. So here you'll get negative 4b minus 3b plus 12 is equal to 0. So b, let's take b common, b minus 4, and here negative 3, let's take common, here it remains b minus 4 is equal to 0. And so here b minus 4 is a common, and here remain b minus 3 is equal to 0. Therefore, b is equal to 4 or b is equal to 3. So we have the value of b. Now let's find the value of h is equal to 7 minus b. So the value of h is equal to 7 minus 4 or 7 minus 3. And therefore, the answer is 3 or 4. Therefore, from our triangle, let's draw it here. Here we have 12. Base is equal to 3 or 4, and height is equal to 3 or 4. So you can take either 3 or 4. Also, you can take like this, 4 or 3. Whatever you take, you get the same area. So let's now find the area of our triangle. So area is equal to half times height 4 times base 3. Here you get 6 centimeter square. And this is the area of our triangle. Let's now move to the second question. The second question says, in triangle PQR, PQ is equal to 12. We have this triangle. PQ is equal to 12 and RQ is equal to 9. We have 9 here and here we have 12. Find the value of sine x, cos x, and tan x. X is the angle. So we have to find the value of sine x, cos x, and tan x. Our triangle 9, 12, and here we have x. From definition of sine, sine is equal to opposite over hypotenuse. But we haven't the value of hypotenuse, so let's first find the length of hypotenuse. So length of hypotenuse, h, is equal to, by Pythagoras theorem, 12 square plus 9 square. So h square is equal to 144 plus 81. And here we get 225. So h is equal to, put square root both sides, is equal to 15 centimeter. So now let's find the value of sine. Now our triangle is, here we have 15, we have 9, and here we have 12. So sine x is equal to opposite over hypotenuse, so is equal to 9 over 15, which is equal to 3 over 5. Also, cos x is equal to adjacent over hypotenuse, so is equal to 12 over 15, which is equal to 4 over 5 if you divide by 3. And also tan x is equal to opposite over adjacent, opposite over adjacent. So this is equal to 9 over 12, which is equal to 3 over 4. Or we may take the ratio of sine x over cos x, so we can get the value of tan x. Let's now move to the third question. In a triangle ABC, BC is the shortest side. So we have triangle in which we have right angle triangle ABC. ABC. BC is the shortest side, means length BC is the smallest length compared to this another side. Also, you are given the value of sine A, which is equal to 5 over 13, and AC is equal to 26 is the hypotenuse. So hypotenuse is AC, which is equal to 26 centimeter, and also we have sine A is equal to 5 over 13. So find length AB and cosine of angle A. So here we have to find this length, and also we have to find the cosine of A. This is A. So first we have to find the length AB and then cosine of A. Length AB, we can use here, we can't use, but we are given the sine of A. Sine of A is equal to opposite over hypotenuse. So first let's find the length BC so that we can find the length AB. So we have sine A is equal to BC over AC. BC over AC. But sine A is equal to 5 over 13 and AC is equal to 26. Now let's find the length BC. Let's cross here, you get 13 times BC is equal to 5 times 26. So BC is equal to 5 times 26 over 13. Here we get 10 centimeter. So from our figure here, BC is 10 centimeter. Now we can find the length AB by using Pythagoras theorem. From Pythagoras theorem, 26 square plus is equal to 26 is the hypotenuse. So 26 square is equal to 10 square plus length AB square. So here length AB square is equal to 26 square minus 10 square. Here let's use difference of two square, 26 minus 10 and 26 plus 10. So here you get 16 and here you get 36. Here we have AB square. So let's now put square root both sides. So AB is equal to square root of 16 times the square root of 36. So AB is equal to 4 times 6, which is equal to 24. Therefore, length AB is equal to 24 centimeter. Also, we have to find the value of cos A. We have here 26, here you get 10, and here you have 24, and this is A. So cos A is equal to adjacent over hypotenuse. This is adjacent 24, and this is hypotenuse 26, which is equal to, divided by 2 here. In each term we get 12 over 13, and this is the value of cos A. Let's now move to the fourth question. The fourth question says find the value of x without using table. We have cos x is equal to sine of 47. We have cos x is equal to sine of 47. But we know that sine of angle is equal to cos of 90 minus that angle, and also cos of any angle is equal to sine of 90 minus that angle, provided that the angle starting from 0 and is less than 90, acute angle. So here, instead of writing sine of 47, so cos x is equal to cos of 90 minus 47. So here x is equal to 90 minus 47, which is equal to 53. So therefore x is equal to 53. Also, we have question 4b. Given that cos 12 is equal to this one and cos 78 is equal to this one, without using table, find the value of tan 12. We know that tan of angle is equal to sine, the ratio of sine of that angle. For here we have angle is equal to 12 over cosine of that angle. But here we have the value of cos 12 and cos 78. We haven't the value of sine 12. So let's convert this sine into cos. So here if we write cos, here we write 90 minus 12. And here over cos 12, this is equal to cos of 78 over cos of 12. And here we have the value cos of 12 of 78 is equal to 0 0.2 0.2079 0.2079, and cos 12 is equal to 0.9781. So therefore tan 12 is equal to, let's multiply by 10,000 to remove the decimal. So here you get 2079, and here you get 9781, and this is the value of tan 12. Let's move to our last question for today. The question says simplify this expression, or we have to calculate the value of this term. So we have tan 60 plus cos 30 over sine square of 45. So here we have common angle. Let's try. Here angle 45, and also another triangle here 6 degree. Here we have square root of 3, here we have 2, and here we have 2. Here we have 1, and here we have 2. So now we can use these two triangles to simplify our equation. So here we have tan of 60. We know that tan is equal to opposite over adjacent. So tan of 60 is equal to square root of 3 over 1 plus cos of 30. Cos of 30 is equal to sine of 90 minus 30, and here we have sine square of 45. So sine of 45 is equal to opposite over hypotenuse. So here we get 1 over square root of 2, but square, because here sine square of 45. So this is equal to square root of 3 plus, here I get sine of 60. From here, sine of 60 is equal to opposite over hypotenuse, which is equal to square root of 3 over 2. So here, sine of 60 is equal to square root of 3 over 2, and 1 over 2 square is equal to 1 over 2. 1 over square root of 2 square is equal to 1 over 2. Now, square root of 3 plus, here we have square root of 3 over 2 divided by 1 over 2. This is equal to square root of 3 plus square root of 3 over 2 times 2 over 1. So this is equal to square root of 3 plus square root of 3. And the answer is equal to 2 square root of 3. Let's finish with last question. A tree 10-meter long is 10 meters away from point A. So here we have point A, and here we have our tree 10-meter long is 10 meters away. Means here 10 meters away. Find the angle of elevation at the top of the tree from point A. We have to find the value of angle of elevation from point A to the top of a tree, this angle. So let's find the angle. Let x be the angle. So here we have the length of opposite and the length of adjacent. So here we can use tan. Tan of this angle is equal to 10 opposite over adjacent also is equal to 10. So here tan of x is equal to 1. Here we have tan, so we have to find the value of tan inverse of 1, which is equal to tan of 45. From this, if we find that tan of 45 is equal to 1 over 1, which is equal to 1. So here, instead of writing 1, we can write as tan of 45. And here we have tan x. So we have tan, and here we have tan. So x is equal to 45 degrees. Therefore, the angle of elevation is 45. And this is the end of the solving in Pythagoras theorem and trigonometrical ratio. So goodbye, see you next time.